Okay, so we left off, we were doing conditional probability with the multiplication rule, and we ended by doing, I showed you your first example of a probability tree diagram, and then we did some multiplication rule, but then we also did the at least rule. And the general rule, when something says at least, you very often will end up applying the complement, okay? So the last page here, and I had said yesterday we ended that this page is kind of a really good full problem for what you're very likely to see on the AP exam for conditional probability, whether it's a free response or in a multiple choice format. In January 2010, the Kaiser Family Foundation released a study about the influence of media in the lives of young people aged 8 to 18. In the study, 17% of youth were classified as light media users, 62 were moderate, and 21% were heavy media users. Of the light users who responded, 74% described their grades as good, A's and B's. 68% of moderate and 52% of heavy users described their grades as good. All right, so I had said yesterday, I prefer to make my tree diagrams vertical. Your book does them horizontally. I don't know why, but for some reason, I feel more organized. I like to go top to bottom. So I'm going to start with all the youths that were surveyed. And those youths were separated into 3 groups. Okay, we had light, moderate, and heavy users. So I'm going to separate this into light, moderate, and heavy. Now, I'm inconsistent how I do it. Sometimes I label the probabilities along the line, and I put the categories here. Sometimes I reverse it. It doesn't matter. But the bottom line is I have 17% were light media users, 62% were moderate, and 21% were heavy. And what I had said yesterday, when you make a tree diagram, the nice thing about having that is you get the tree diagram set up and then you can answer any question about it that you want, okay? So I'm gonna make sure now I'm gonna split each of these, and each group now was split into, they either said that I have good grades, A's and B's, or apparently bad grades, or C's, D's, and E's, okay, or F's, whatever you want to call them. So I have good grades and I have bad grades. And for the light media, I have 74% said I have good grades. For medium, they said 68% said they had good grades. And for the heavy users, they said only 52% said they had good grades. Now you'll notice on this one, you have to figure out the rest of it yourself. At any level, it ought to add up to 100% because all the youths were split into 3 categories. Okay, so these numbers will add up to 100. Now at this level, all the low users were now split into 2 groups. So these 2 things have to add up to 100%. So there must be 26% of them had bad grades. For the moderate users, we must have 32% had bad grades. And that's supposed to say bad. And for the heavy users, it must be 48% had bad grades. Let me rewrite that, it's hard to read. So with a tree diagram now, you can go through and you could now read any branches and say, I have low users, but good grades. I have low users, but bad grades. Moderate users, good grades, moderate, bad grades. Okay, so you can go through any trail you want. So the question now says, what percent of people aged 8 to 18, that's all of these 8 to 18, who describe their grades as good? Okay, so I want the probability that they said my grades are good. Well, I can see all the G's right here, But then I realized I'm going to go up backwards and say the good people came from this trail. So basically what I have is I have 0.17 multiplied by 0.74 is one trail. I have 0.68 times 0.62 as another trail. And then I have the 0.21 and the 0.52 as the other trail. And basically what you have going here is to get your overall answer, you have, these are the people who are, this is the probability that they are a light media user and got good grades. This is the probability that they were a moderate user and got good grades. Probability that they were a heavy user and got good grades. And to get the overall answer, if you just want to know who had good grades, it could be the low good, the moderate good, or the heavy good. And the word or implies that we're going to add these together. So the tree diagram yesterday, to be honest, there was no purpose on the tree diagram yesterday except to show it to you. We could have just done this problem very easily right from that. But the tree diagram will allow you to see multiple possibilities at one time. All right, you should, just so you know, you could type that in your calculator all in one stretch. You wouldn't have to like use parentheses or anything. You could just do 0.17 times 0.74 plus and continue. I have overall, it should be 0.657 approximately. So about 66% of all people, all the youth age 8 to 18 said, I have good grades. Now it says, given that the person said their grades were good, find the probability that he was a heavy media user. All right, so I want the probability that he was a heavy media user, given the fact that he described his grades as good. Okay, so what happens on this one is, because I have a given, it means I don't want to look at the entire group anymore. It's just like on the two-way table. When there was a given, okay, when there was a given, I didn't use the 500. I used only the 340 or the 310 on this example. I don't want to use all 100 people. If I want the given, their grades are good, I only want to look at that 66%. That becomes my denominator. I'm only going to look at those students. I only care about if your grades are good. Now, what's the probability that you were a heavy media user? Well, the heavy media user was this group right there, the 21% of the 48%. Now, the common mistake that people will do on this is they will choose either just the 21 or just, oh, I don't want the 40, I need the 52. So the common mistake people will do is they will come up here and they will use only one of these two numbers. I have only my good grade people. I just calculated that. One of the things I like to point out to students is when you do these conditional probabilities, very often your numerator will become one of these, I call them chunks, okay? Not just one number or the other, but it will end up being one of those chunks of information, okay? So this comes out to be a total of about 17%. I have 0.166. Now, I did that problem without offering you the formula first. This formula is on the formula page, okay? What I pointed out here, I said, notice that this is just a rearrangement of the general multiplication rule. If I go back and look at the general multiplication rule, if I were to divide, okay, if I look at this right here, if I were to divide by the probability of A on both sides of that equal sign, these would cancel and you will actually get the conditional probability formula. So it's the probability of A and B divided by the probability of A, and that will give you the probability of B given A. Now, what I want to point out also on that is you could move the letters around. Okay, so it's usually written A given B, or it could be the probability of B given A. The numerator is going to be the same either way. It's going to be the probability of A and B. Okay, that really doesn't matter which order you write it. A and B, B and A, doesn't matter. But what you want to remember is the denominator has to be based on the given. So whatever letter is here, that's going to go into your denominator. Whatever letter is here, that goes into the denominator. So if you want to use different letters, or if the A's and the B's are rearranged, just remember that. The given has to be your denominator, because that's the part that we have to say we assume that happened, so we're only looking at those people. Okay, so if they start using different letters on you, don't get freaked out. Okay, the top is always the and between the two. The denominator is going to be the probability of the given. Okay, bless you. All right, so this formula is not given on the formula page in this order. It is given in this arrangement. So you could also then say, I could multiply both sides by the probability of A, and you could then create the multiplication rule. So they give you the addition rule, they give you the conditional probability formula, but then you could use that to create the multiplication rule. So they give you two formulas, but then they really kind of give you three. Okay. All right. So they will sometimes ask the questions like this. They meaning the College Board when they write the exam. They will sometimes do this. They're trying to guide you a little bit. They will ask you a more general question, and then they'll ask you something more specific, and you end up using that answer. Sometimes they don't break it into two parts. They might just go for it, and they'll just say, given that a young person did not describe her grades as good, find the probability that she was a light media user. Okay, so the probability that they're a light media user, given the fact that she said her grades were not good, so in other words, the grades were bad. Okay, so how the conditional probability formula will work, technically, is at the top, it's going to be what's the probability of B and L. Now, it's normally given in that order only because B is the given, so it typically happened first. But if you reverse and call L and B, it's no different, but whatever. And then this denominator goes down here. Keep in mind that the denominator is often, like what I showed you here, it's often a combination of trails. So if I want all the people who said my grades are bad, all the people who said their grades were bad, it's this trail, added to this trail, added to this trail. So it's going to be the 0.17 times the 0.26, added to the 0.62 times 0.32, added to the 0.21 times the 0.48. And very often, the numerator will be just one of those chunks. I want the B and L. I want bad grades and low users, light users. Bad grades, light users. My numerator is going to be the 0.17 times the 0.26. Easiest way to do this in a calculator, honestly, is to do the denominator and the numerator separately and then divide it out. Okay, so if it were me, I would get this answer, I would get this answer, and then I would divide it out. The bottom line is I have the answer is 0.129. So if I randomly pick one person from this group, there's about a 13% chance, okay, if I pick only from the bad grade people, there's about a 13% chance that they were a light media user. This is important for AP in terms of probability. Not that the other stuff you don't need to know how to do it, but this almost always will come up on the exam.
I feel like if it's a part B or something, and we already did like part C, can we just try with like doing 1 minus the good? Or do we have to write that?
If it's appropriate to do a compliment, you absolutely could. Okay, if it's appropriate that you know you're really doing a true compliment, yes, it's okay to do that. But make sure you really have a compliment, that you have all of one versus all of the other. Okay? So honestly, that is everything that is going to be on your next test right there. As of now, the test is scheduled for Tuesday before Thanksgiving. I normally don't like giving tests before break. Okay? 2 reasons. One, parents pull their kids out, they go on vacation. Okay? 2, for the kids who are here, I end up with homework. I'm the one who gets the homework over break. I have to grade all the papers. Okay? The alternative is to either have one less review day and do the test on Monday, which if you're going to be gone Tuesday, that's what I recommend. Just miss one review day, get the test done. Otherwise, we have to wait and do the test on Monday after Thanksgiving. And I'm not sure that is going to be ideal for most of you. So test is on the calendar for the Tuesday before break. So that is 1 week from yesterday, 6 days from now. Okay. If you are going to be gone on that day, I already had one person talk to me about that you can either take the test in class on Monday and skip the review, or you can stay after school on Monday and do it then. Okay? The rest of the time is yours to work on the homework. Either finish up part 2 or do part 3.